I don't like to interfere with the constructor, destructor, update order, because those are the most used functions and I like having them at the top of my file. So I'm just going to pop these initializations in here. Okay, that's looking good. mPlayerPos is an IVEC2, so we can just use IVEC2 constructor like so. Okay, so these will, now we can arbitrarily initialize these at any time just by calling this little function that we made, this helper. Let's put semicolons there, great. Okay, it's getting really bitchy because this whole function doesn't even exist yet. Class player has no member, so we just have to add it in the header. And it's going to be a private function. I don't expect this will be called from outside this class right now, because I expect to actually have a little callback in all the in this actor for handling the orientation change event, which Marmalade actually gives to us. So call this function whenever screen layout or orientation change to update the positions of our screen quadrants that are used for input. That's what this function does. And we can pop that into the header too, so it's not too mysterious. Okay, so that's really easy, and we're recording that in the constructor. Just check, yep, recording that. So that's half the puzzle solved. We now have a helper. Let's look at this a little bit more closely. So we're actually really lucky because Marmalade, the way it works is it will actually give us a screen size based on the current orientation. So if you put it into landscape mode where the screen is wider than it is tall, your screen size, your screen width will be taller, and so you'll just get a nice round, you'll get the right number out of here. So screen size is actually really intelligent, and all of the rendering is based on that, which is really good for us. Now, the next thing I've just noticed is we have a compiler area, because we're assigning an IVEC2 to a left quadrant, which is an iRect. Let's just fix that. That was my mistake. That's better. So the next thing we need to think about is this player pos correct? So it's always going to be in the center of the screen, and that's fine. But is this half quadrant size correct? I don't think so, because that's not even initialized yet. So it's just going to have a look and see where this is used. Oh, went past it. Of course, we're going to have to move these into our little init function too, and make sure that they're not constants. Just see where they're initialized. Yeah, no, they're not constants, so that's fine. We can change them anytime we like. So all of these player pos, left quadrant and right quadrant, are dependent on these quadrant sizes, which also need to be updated, just like we did with these other ones. So they're an IVEC2. Okay, so that's cool. So you can see a half quadrant size. In fact, quarter quadrant size is no longer used, but we'll leave it in here just in case we need it in the future. It's only two integers, so it consumes almost no storage. So that's looking pretty good. I'm quite happy with that. The other thing I want to do is to actually draw the quadrants as well, to make sure that we got the right sizes. And in fact, I want to draw them in different colors. I believe I've already got a piece of code in here somewhere that does that, which would be in the player stuff. Okay, it's no longer here. I'll just do a quick search for quadrants. So I believe I have already written a function that does this quadrant drawing. Roll, no. I might have deleted it. Yeah, I'm pretty sure I've deleted it, but that's fine. It's very easy to draw stuff using AirPlay, particularly if you're in debug mode. So what I'm going to do is I'm going to look in my update. And I want this to happen every frame. I've got a whole lot of stuff here. I'm going to call IWGX debug prim box. Is it a line? Where do we draw the 2D stuff? I forget. Let me just go and have a look. Could have sworn there was a debug primitive function here somewhere. And list. No, I think the draw rect in screen space, that's the one I want. Excellent. I think there was also that's actually not quite the one I want. correct screen space. Well, we should actually be able to use that one. Just see what arguments it takes. There's a really complex version and there's a simple version, so let's go with a simple version. Wow, that's actually going to take quite a while to set up, so I might just pause this and do a quick research. Okay, so after a little bit of research, I figured out exactly what we need to do. We actually want to use the IW2D library, so we need to include a header file for that. That's part of Marmalade, as always, and we can just include it here right at the bottom. 2D. We actually want to include that from our standard include directories, not as a project include. So we'll just make sure that that include is right by just doing a very quick build, because it's not being picked up by Visual Assist. Yeah, okay, it doesn't know about that file, so we're going to have to do a little bit more work. There's actually a sample program included with Marmalade that shows you how to use it. So in that sample program, they're just using this. Oh, of course, I know. In Marmalade, what you need to do is you need to. Did I get the case of that right? Let me just check. Yep, that's right. So in Marmalade, you actually have to edit a file in your project, which I'll show you. It's called the MKB. I believe it's called MKB, which is a version of a kind of a make file that you use to create your projects. And what you have in this make file is a bunch of sections which specify options when you're deploying your project. So what you want to do here is actually add in the module as a sub-project, and you'll just have to restart Visual Studio. So I will just do that now, and then you open up the MKB. So I will just grab that MKB and it's just in my P4 directory and over there. So I'll just double click on that to start the project building. Okay, because I've changed the sub-project, it's actually deleted a whole bunch of object files, which is fair enough. We'll just have to do a quick build to get everything working. But now, if we go back to our player file, I can't remember exactly which file it was, but now we should have it. Yeah, now you see, now Visual Studio and Visual Assist both picking up the header file because it's been included in our include parts in the project. So that's very straightforward. So what we're going to do is we're going to start the build going so that by the time we finish writing the code, it'll be ready to go. Okay, so we were going to add some 2D lines to show the quadrants. It's very simple. All you do is you call IW2D line, draw line, and it takes two arguments, 2 points, I should say. They're just integer points indicating the start and end of the line. So we're just going to look a little bit more closely at the documentation. Okay, so there's not a huge amount of information here, but I'm assuming that these are going to be screen space points. So we may actually just bring up the Marmalade documentation. I'm still using a slightly older version, so it may not be completely the same as the latest Marmalade stuff. And let's go and have a quick look at that function, because I'm not 100% sure what those coordinates are. Are they screen coordinates or what? Let's go and check that one out. Let's have a quick look. Okay, so this is an example of its use, yes, but it's not using the actual draw line. That's interesting. Oh, that's a shame. Okay, here we go. Here's the reference. That's what I was looking for. Context? No. It's not it. It must be in the miscellaneous functions. No. Ah, here we go. Primitives. Draw line. So let's look at that one's documentation. So this is pretty much the same as the function, because I believe these comments are actually pulled out. So what we can do is we can look at some other functions to just sort of get an idea. I believe these functions are all taking screen pixels. So if we look at the overview, this provides a 2D drawing layer. So I'm just trying to see here if it says which coordinate space all these coordinates are. So here's an example. This is actually good. Okay, so if we look at this one, draw a rectangle, they're drawing a rectangle of at position 10,10. So this clearly looks like actual screen pixel coordinates to me. So that makes a lot of sense. If this was like, for instance, screen space or view space, so this would be probably a value smaller than 1, or definitely wouldn't be greater than 1. So that's good. Okay. We had a bunch of compile errors, but that's fine. We'll get across to them and fix them. We're sort of halfway through this change. We just wanted to catch up after redoing the MKB. Alright, so that's easy. So the start and end of these quadrants, we already know what the positions are. So vec2 is just an integer vector. It takes 2 arguments in this constructor, an x and a y. So that's quite straightforward. So if you recall, we had these quadrants and their sizes. So what we can actually do is just pull the coordinates out of that quadrant over there. So it's left. We're actually going to have to draw a rectangle. So I think IW2D actually has some rectangle drawing functions, yeah, which would make our life a little bit easier. So left quadrant. Actually, we have to make a vector first of all, and then our left quadrant. Left, and and we're starting in the top of the screen, so we can just use 0, and then we want the bottom right hand one. Oh, actually this is a size, so we can just use the quadrant sizes, which is very convenient. Dot left. I should have added in a width function here, but that's fine. We'll just use right minus left. Coordinates will always be greater than 0, so that should work fine. And in fact, I'm going to refactor this because this is starting to balloon into a quite large function call. So that's just the x, and then we do the y, which is the bottom minus the top. So that's defining for us a size of a rectangle plus the position of the top left-hand corner of the rectangle when we call this function. So that will do the left side, and then we just duplicate that for the right. And we just replace the names, and that should do the trick. In fact, you could specialize this even further and turn the quadrants into a first-class object. But I don't think that will be needed because we're not going to be using them that much in this particular way that we're doing. So the next thing to do is to actually examine what color these things are being drawn in, because I'm not really sure. There is no color argument to these functions. So if you look at the drawing primitives SDK documentation again, you'll see there's actually an example here where they do set color. So obviously this is being used to set some sort of material state or a material color that's used before these primitives are rendered. That's really easy, and if we look closely here, this looks like it's taking an RGBA, or actually no, because those FFs are at the beginning, I'd say it's most likely an ARGB color, but let's go and have a quick look. This sets the color for subsequent drawing operations, that's what we thought. So the color, this 32-bit number is an ABGR. Okay, so that's fine. So that's black with full alpha, so that's cool. We just want to draw something very, very simple, so we're not going to go into any crazy colors. So this color that's being drawn here, and I prefer using uppercase, it looks more hexy, is red. So we'll use red for left. And our ARGB, well, let's use green for the right. Oops. So that, actually it's RGB, that'll be blue for the right. I put the wrong one in here.